As we finish up our study of the graphs of trigonometric functions, we're going to finish with tangent and cotangent. Remember, when we started learning how to graph sine and cosine and secant and cosecant, we began by looking at a table of values. And then we transferred that table of values to a coordinate plane and graphed and came up with patterns for the graphing each period. And we learned from those patterns how to graph sine and cosine, secant and cosecant. We're going to do the same thing now with tangent. So what I'd like for you to do is either take out your unit circle or from memory, evaluate each of these trig functions. For example, I'll do the first one with you. This asks for the tangent of negative pi over 2. I know that if I look at the unit circle, negative pi over 2 is at 270 degrees, or the negative y-axis. The ordered pair at this position is 0, negative 1. Using that ordered pair, we know that tangent is equivalent to y divided by x. So we know that at negative pi over 2, tangent is undefined. Would you please pause the video and complete the table finding the tangent of these other trig functions. Then turn the video back on and check your answers. All right, let's see how you did. These are your values. Tan should be undefined at negative pi over 2, positive pi over 2, and 3 pi over 2. So tangent is always undefined where x is equal to 0. Tangent at negative pi over 4, 3 pi over 4, and 5 pi over 4 is either 1 or negative 1, depending on the quadrant. And the tangent of 0 and pi is 0. Remember, the ordered pair at 0 is 1, 0. So tangent is 0 divided by 1, which is 0. The next thing I'd like for you to do is to pause the screencast and place these angle measurements along the x-axis and then plot the y values along the y-axis or in the y direction. Take a moment and do that. Let's check out what you graphed here. First, I labeled the x-axis with each of these angle measurements. And recall that when a function is undefined, we show that with a vertical asymptote. So I have vertical asymptotes at negative pi over 2, and 3 pi over 2. Then I plotted the ordered pair negative pi over 4, negative 1, 0, 0, positive pi over 4, positive 1, and then connected those dots. And you may be wondering, well, why doesn't this just make a linear function? Well, if this were linear, this would continue across the asymptotes. And we cannot cross the asymptotes. Remember, that's where the function is undefined. Also recall that if I think of the angles between pi over 4 and pi over 2, for example, pi over 3, we know the tangent of pi over 3 is the square root of 3, which is approximately here. So if we kept on plugging in angles 61 degrees, 62 degrees, 63, 64, 65, tan would continue to increase as it approached pi over 2. But when we get to the tan of pi over 2, or 90 degrees, we see that it becomes undefined. And then this pattern repeats itself between pi over 2 and 3 pi over 2. So let's figure out what is the length of one period of tangent. I see that I have this pattern drawn 2 times, so it repeats itself after each set of asymptotes. So if we'd like to find the period length, we would find the distance from negative pi over 2 to positive pi over 2, or negative 90 degrees to positive 90 degrees. How many degrees separate these two? Negative 90 is 90 degrees plus 90 more. Okay, these two are separated by 180 degrees. What about from 90 degrees to 3 pi over 2, which is 270 degrees? 270 minus 90 is 180, so it repeats itself again after 180 degrees. So the length of one period for tangent is 180 degrees, which is equivalent to how many radians? And that's pi. Good. So the period length for tangent is different from sine and cosine. Sine and cosine repeat every 360 degrees or every pi radians. So if we want to calculate the period for tangent when we're looking at equation, the formula is not 2 pi over the absolute value of b, but 1 pi over the absolute value of b. Okay, well, where is tangent undefined? I see it's undefined at negative 1 pi over 2, positive 1 pi over 2, 3 pi over 2. If we kept going and followed a pattern, the next asymptote would be at 5 pi over 2, and then 7 pi over 2. If we went to the left from negative pi over 2, we'd have negative 3 pi over 2, negative 5 pi over 2. So you can see that these are odd multiples of pi over 2. So tangent is undefined at odd multiples of pi over 2. So where is the starting point and the ending point of a period? Well, we could choose any of these asymptotes that we wanted to, but so we are all doing the same thing. We will say that the starting point is negative pi over 2, and the ending point is positive pi over 2. Notice, let me say again, let me point out again that tangent begins and ends between these asymptotes. So we're using our asymptotes as the starting point and the ending point. So how do we find these asymptotes when we have a period change or a phase shift? Anytime that the period changes or we have a phase shift for tangent, we will take the values for bx plus c and evaluate them between negative pi over 2 and positive pi over 2. And then we'll solve for x or theta, depending on the variable. So remember, these are our starting asymptote of the parent function, and this is the ending asymptote of the parent function. That'll tell us where to draw in between. A couple of other things I want to point out. I want you to see that tangent crosses the x-axis halfway between the two asymptotes. What's halfway between negative pi over 2 and positive pi over 2? 0. What's halfway between pi over 2 and 3 pi over 2? Pi. So we cross the x-axis halfway between the asymptotes. Notice that we still have the period divided into 1, 2, 3, 4 equal parts, just like we did with sine and cosine. So we divide into 4 equal parts, and then because tangent rises to the right, our first point will be at the negative value for A, our second point at 0, 0, and our third point at the positive value for A. Let's try an example. Example G. I noticed that the equation y equals the tangent of x over 2 causes a period change because b is some other value than 1. So let's figure out the new asymptotes. If the period changes, the asymptotes will stretch further apart or shrink closer together. Remember, we said that tan's asymptotes are at negative and positive pi over 2. So let's put x divided by 2 between negative pi over 2 and positive pi over 2. In order to isolate x, we would multiply each portion of the inequality by 2. In this case, the 2's cancel, and we have negative pi is less than x is less than positive pi. So this tells me that my asymptotes stretched out from negative pi over 2 to negative pi, and from positive pi over 2 to positive pi. Whoops, that was too big, wasn't it? Let's immediately go on and mark these as asymptotes. Okay, remember, let's divide the period up into 4 equal parts. Halfway between negative pi and pi is 0. And then we have our quarter mark to the left and our quarter mark to the right. If we look at this equation, the coefficient of tangent is 1. So we should have the y-axis labeled with positive 1 and negative 1. So let's make sure that we have this labeled. And let's follow our pattern to graph tangent. We begin with our asymptote. Tangent rises to the right. So at our first quarter mark, we will be at the negative value for a, which is negative 1. The halfway mark, we will be in the middle on the x-axis. Our 3/4 mark will be at the positive value for a, or positive 1. And here's our graph for tangent. Now we've only graphed one period, so I want us to think about, if I ask you to graph a second period, you know that you would have to go out this distance for your next asymptote. So here's the asymptote. We can divide this into 4 equal parts, plot our points, and draw the second period of tangent. But you know that I think it's important on the x-axis to label each endpoint. So we've got to figure out how can we determine how many radians this last asymptote is. We know that this distance between asymptotes represents 1 period. So if we know the length of 1 period, we can add it to pi, and that will tell us where the second or the third asymptote is located. Recall, to calculate period for tangent, the formula is 1 pi divided by the absolute value of b. In this case, b is 1/2. And how do we divide by 1/2? We keep it, we switch to multiplication, and we flip it. So the period is a length of 2 pi. So 1 pi plus 2 pi is 3 pi radians. Let's look at example H. I see that I have bx plus c is 2x minus pi over 2. We know that we will have to place those between negative pi over 2 and positive pi over 2. Let's sweep the fractions. In order to do that, we would multiply every portion of this inequality by 2. So when we do that, this gives us negative pi is less than 2 times 2 is 4x minus the pi, this 2 will cancel, is less than, and this 2 will cancel. To isolate 4x, we would add pi on the outsides in the middle. So if we add pi here, we have 0 and 2 pi. And then we would divide by 4. So our asymptotes are at 0 and pi over 2. Divide that into 4 equal parts. Halfway is pi over 4. A is negative 1 and positive 1. So we have negative 1, 0, and positive 1. Please finish this last example and bring it to class tomorrow.